know how far down to go. Can you compress it?
Oh,
Yeah, exactly.
I compressed it from here to 1/3 its size. So I took 1/3 of this distance, whatever the distance is. You can just estimate it. I mean, remember, we're only dealing with estimations anyway. So what you can do is you can say, well, 1/3 of this distance from here to here is about there, isn't it?
Oh, okay, yeah.
It's 1/3. I mean, I just guessed. I just said 1/3 is about that big. If it had said 2/3 up here, then I would go to here, wouldn't I?
Yes.
Okay, I just guessed. You can actually count it and divide it, but it's better to just estimate.
That's the only thing I didn't get.
Yeah, I think you did it right. That's a good idea. Okay. Let's graph this one. Let's go to our new vertex first. And not only that, guys, I'm going to graph this one on purpose. I'm going to graph this one first. Because this one I can graph and then I can stretch it to get this. So I'm going to graph the blue one.
That's a new graph?
Yeah, I'm going to graph the blue one and then I'm going to stretch it to get the black one.
Oh,
Because it's twice as high. See it? See the two?
Right?
Yeah, it's going to be twice as big.
okay.
Now, the question is, where's our vertex though?
0, 5,
5, -4. However you have to reconcile that -4 business, you got to do it.
What did that say?
Vertex? Now, y'all know what the -1 does?
No.
Make it go down?
Goes down instead of up. It's a negative, right? It reflects it down.
So one down.
But it's a -1, so that means that it's standard shaped.
But
That
it's
means
still the 1, -1,
1, 2, 4, 1, 2, 3, 4,
1,
3, 1, 2, 3, 9.
1, 2, 3, 4.
There's one more extra.
This is hard. That's a standard. Everything's easy to accept it, right?
I don't know how to do
What?
Mister, how do you do that? How do you,
How do I do what?
like, with the
Oh, how do I know how far it goes?
Like, how do
Well,
you know? How do you
1
know?
squared is 1, 2 squared is 4, 3 squared is 9, right?
You just square 'em?
So I took 1 away from the vertex and squared it and got 1. I went 2 away from the vertex and squared it and got 4.
Hey, mister,
The negative makes it go down.
can we just plug that into the calculator?
Oh.
Yeah, except when you get to these,
Which one?
if you did these,
No,
you have to
those?
solve for
No,
y.
no, I understand those, but
Yeah.
the other ones.
Yeah, you could. Yeah.
You
You could stick it in a calculator, you would get this answer. If you happen to have a calculator on you.
Oh, yeah.
Yeah, there's some there. All right. Now, y'all see that I have a 2 here? So I'm going to go from here, and what I'm going to do, what I like to do, guys, is I like to choose a point that maybe I know for sure, like this one. You see, I know this point for sure, don't I, right here? And this point, I'm going to double it. Instead of it going to 2, 4, or 2, -4, it's actually going to go to 8 instead. So this point is going to be 1, 2, 3, 4. It's going to be twice as far. Everybody follow what I did? I'm going to stretch it, and it's going to look like this instead. That's a stretch. I have one last one I want to address, and I want you to be careful of something. A lot of people want to learn that if it's a fraction less than 1, then it's wider. I would prefer if you think of it as a compression. And if it's greater than 1, it's a stretch. It works better because sometimes you have what look like sideways parabolas. They're like this. And I'm going to pick some values of x that work really nice with the radical, like 0 and 1 and 4 and 9. Go ahead and finish your table and graph them.
Okay, I got it. Take my borrow.
I chose my domain nice and easy on purpose. The square root of 0 is 0. The square root of 1 is 1, because 1 times 1 is 1. Square root of 4? 2. And the square root of 9 is 3. Now, here's what happens. We go to 0, 0, 1, 1, and then 4. 1, 2, 3, 4, 2. And then 9, 3. And doesn't this look like half the parabola? Doesn't this look like half of a parabola? It's only the positive side, because you can't get negative, you don't get negatives when you take a square root. You only get positives here. Now if I want the bottom half, I would have to put a negative in front of it, wouldn't I? That would give me this bottom half. If I wanted to multiply it by a number, it would stretch it. If I multiplied it by a fraction, it would compress it. Does everybody see that that wider, narrower business doesn't work all the time? So you need to be careful of that. Let's do one last one. Turn that over. Grab that one. I'm going to put my vertex in black on purpose because the vertex is part of the graph. Where is the vertex? 3, 4. Now, if this was a 1, then it would look like this. If it was a 1. Let me put it in blue.
So since it's negative 2, it's just going to go straight to 4?
Be careful. If it was a positive 2, then it would be like this. It would be twice as tall because it would be stretched. But since it's a negative 2, it goes down and stretched. So a negative 1. A negative 1 looks like this. A negative 1 would be right here. But a negative 2 is twice as tall, so it's stretched. Ends up looking like this. That's my black graph right there.